What if you could lose months of hard-earned fitness in less than 2 weeks without feeling a single thing? That's exactly what researchers discovered when they started measuring what happens inside the body the moment regular exercise stops. Not months later, not years later. Within days, the systems that keep the heart strong, the muscles energized, and the brain sharp began quietly shutting down long before most people notice anything at all. And the timeline of that process is far more aggressive than anyone expected. So how quickly does the human body actually start losing fitness after exercise stops? And why does it happen so fast? Because the answers reveal something surprising about how the human body was designed to move. Here's a question that sounds simple but has a surprising answer. How long does it take for a fit person to start losing measurable fitness after they stop exercising? Most people guess months. The real answer is closer to 10 days. And what makes that number so striking is that most people who stop exercising for a week or two feel almost completely normal on the outside. Energy levels seem fine. Muscles still look the same in the mirror. There are no obvious warning signs. But inside the body, a quiet and systematic process of adaptation has already begun. Picture a healthy man in his early 40s. He runs a few times a week, lifts weights, maybe walks on the weekends. His cardiovascular system has adapted to handle that demand. One thing that changes with regular training is blood plasma volume, the liquid portion of blood that carries oxygen and nutrients to working muscles. When someone trains consistently, the body expands this plasma volume, allowing the heart to pump more blood with each beat and deliver oxygen more efficiently. But within about 7 to 10 days of stopping exercise, that plasma volume begins to drop. As it falls, the heart has to work harder to move the same amount of oxygen through the body. Heart rate during activity starts creeping upward. Effort that used to feel easy begins to feel slightly harder, even though nothing externally has changed. The body isn't waiting for permission. It's already adapting to the new normal, and the cardiovascular system is just the beginning. Here's something most people don't know. There's a single measurement that scientists consider one of the strongest predictors of how long a person will live, and it starts declining within 2 weeks of stopping exercise. That measurement is VO2 max, the maximum amount of oxygen the body can use during intense physical effort. It reflects how efficiently the entire oxygen delivery system is working, from the lungs to the heart to the muscles. People with higher VO2 max scores tend to live longer and experience fewer chronic diseases. And multiple studies have found measurable decreases in VO2 max in as little as 2 weeks after training stops. What's driving this decline? Partly the blood volume drop already mentioned, but also changes happening deep inside the muscle cells themselves. Inside each muscle fiber, there are tiny structures called mitochondria, the energy factories that convert oxygen and nutrients into usable fuel. Regular exercise increases both the number and efficiency of these mitochondria. When exercise stops, the body begins reducing mitochondrial density because that capacity is no longer needed. Less oxygen is being consumed, less energy is being demanded. So the body scales back its infrastructure and endurance begins to fall with it. Someone who could run 5 miles comfortably a few weeks ago may find themselves breathing harder than expected after just 2. Not because they've become a different person, but because the internal machinery that made that run feel easy has already started powering down. Now here's where it gets interesting for anyone who lifts weights. Most people assume that muscle is the first thing to go when training stops, but the reality is more complicated and more revealing about how the nervous system actually controls strength. Muscle fibers themselves are surprisingly resilient. They don't shrink dramatically in the first few weeks after training stops. What does change quickly, however, is the nervous system's ability to recruit those fibers. Strength is not just about how much muscle someone has. It's about how efficiently the brain communicates with that muscle during a movement. That neural coordination built through repetition and load begins to fade without regular practice. Within a few weeks of stopping training, strength can begin to decline, not because the muscle has disappeared, but because the brain is no longer optimized to use it. Movements that once felt smooth start to feel effortful. Weights that were manageable suddenly feel heavier. Coordination that felt automatic now requires conscious effort. This is one of the most underappreciated aspects of fitness. A significant portion of what people call strength lives in the nervous system, not the muscle. And the nervous system is fast to adapt in both directions. Beyond the muscles and the heart, there's a deeper system quietly changing in the background. one that connects exercise to metabolism, body composition, and long-term disease risk. Regular exercise improves insulin sensitivity. This means the body becomes more efficient at moving glucose from the bloodstream into muscle and other tissues after a meal. Blood sugar stays stable, energy remains steady, and the risk of metabolic disease stays low. When exercise stops, insulin sensitivity begins to decline. Glucose lingers longer in the bloodstream after meals. The body becomes more likely to store excess energy as fat. Over time, this can shift body composition and contribute to the development of conditions like type 2 diabetes. And the effects don't stop at the body. Exercise stimulates the release of a protein called BDNF, brain-derived neurotrophic factor, which supports the growth and connection of neurons. It's one reason regular exercisers tend to have better memory, sharper focus, and more stable moods. When exercise stops, BDNF levels begin to decline. Mental energy, motivation, and cognitive clarity can all soften in the weeks that follow. Many people who take extended breaks from exercise report feeling mentally sluggish or emotionally flat. And now there's a biological explanation for exactly why that happens. What emerges from all of this is a picture of fitness not as a static achievement, but as an active, ongoing biological state, one that requires a continuous signal to maintain. This is where the science becomes genuinely fascinating, because there's an obvious question underneath all of this. Why would the body dismantle its own fitness so quickly? The answer lies in evolutionary biology. For almost the entire history of the human species, physical inactivity was a signal that something was wrong. A person who wasn't moving was probably injured, ill, or conserving resources during a scarcity period. Under those conditions, maintaining expensive biological infrastructure, a high-capacity cardiovascular system, dense mitochondria in every muscle fiber, finely tuned neural coordination would be a waste of energy. So the body evolved a simple rule: use it or lose it. Fitness is expensive to maintain. If the signal for demand disappears, the body begins winding down the systems that serve it. In modern life, this creates a mismatch. People stop exercising not because they're conserving energy for survival, but because of work schedules, minor injuries, life stress, or plain exhaustion. But the body doesn't know that. It only responds to the signal. And when movement stops, it begins adapting as if the demand will never return. The good news is that this same adaptive system works just as powerfully in reverse. The body doesn't just respond to decreased demand, it responds to increased demand just as quickly. And here is one of the most encouraging findings in exercise science. Something called muscle memory means the body can rebuild lost fitness significantly faster than it built it the first time. Muscle cells retain structural changes from previous training. The neural pathways don't disappear completely. When exercise resumes, the body recognizes the signal and begins restoring its systems at an accelerated rate. Blood plasma volume expands again. Mitochondrial density rebounds. Neural coordination with muscle fibers improves within days of returning to training. What took months to build the first time can often be substantially restored in weeks. That first workout back will still feel hard, but the body is already listening, and it responds faster than most people expect. So what does all of this actually mean? The human body is not a fixed machine. It is a dynamic, constantly adapting system that responds to the demands placed on it. Exercise is not simply a way to get fit. It is a signal one the body evolved to expect that tells every system to stay ready. When that signal disappears, the body begins a quiet, systematic withdrawal. When it returns, the body begins rebuilding just as systematically. This means the goal of exercise is not a destination. It is a practice, not perfection, but consistency. Because even small amounts of regular movement, a walk, a short run, a brief lifting session, are enough to maintain the signal that tells the heart to stay strong, the mitochondria to stay dense, the nervous system to stay sharp, and the brain to stay clear. The body evolved expecting movement, and given even the smallest reason to stay ready, it will.